Hi, my name's Simon, VK2KU. I'm part of the Illawarra Amateur Radio Society, and I've been working on a setup of Crossways noise cancellers. I'm just going to point out something straight away. This is a very old design. A lot of people have made this. The actual design dates back a long way, back to pre-World War II. So this is nothing new. It's just something I've done for one of my friends who had all kinds of problems with HF noise. So I sort of tried to help him, and in doing so, discovered a whole lot more about Crossways noise cancellers. Does anyone here have a lot of noise at home? There's always a problem, isn't it? And there's a few misconceptions about how these work, which I've kind of discovered along the way. Has anyone ever used a Crossways noise canceller? Do you have a lot of success with it? Not you. Yeah, some. Yeah, so. Yeah, okay. I'm going to try this. Right. So, what sort of things creates this? Well, what devices cause the noise around our homes mostly? I know around here's another part of it. I don't get on HF very much, so it might surprise some people, but I do know a few of these things do cause a lot of problems around the house in the local area, which do cause me problems whenever I do set up some HF radios at home. Switching power supplies, I know. Ooh. What do you think, Keith, over there? Switching power supplies? No, he's definitely not.
The cheap ones.
Yeah, correct. I've actually got a mobile phone charger, well, my wife does. When she plugs that in, there's no HF in the house for me. It's crazy. Solar systems, I've got solar on my roof. I know during the daytime it makes a bit of noise. Power LAN or PLM, is probably not so common anymore. Remember the modems that you used to be able to plug into the PowerPoint? And then well, it's not a modem, it's like an adapter, and you can plug your Ethernet in. You have Ethernet over your 240 volts in your house. Some computers, especially my laptop, my work laptop's a problem. Microwaves, televisions, phone chargers. Yeah, everything. Oh, the inverter ones, inverter air conditioners. Yeah. Yeah, LED lighting. All you mean like the down lights in the roof, those sorts of things. Yeah, all of these things pose a problem when we're trying to get HF working at home in the shack. So, a little bit on Crossways noise cancellers. Earlier ones, if you go looking around, some of the archives, they used to be called receiver noise cancellers. And if you dig around for some information, I couldn't actually find any pictures, but I did do a bit of reading. These have been around since before World War II, or developed pre-World War II. And back then, the noise antenna was actually called the diversity antenna. I don't really understand why or where that came from. And the basic principle of it is you have a noise antenna and you have your main antenna. And what happens, you receive the signals on both your noise and main. Your noise antenna wants to really only pick up noise, and your main antenna wants to pick up noise and your main signal. And what we do with the signals, we flip the signal on the noise antenna at 180 degrees, and we mix it with a signal on the main antenna, and what you're left with is just your signal that you're after. That's the concept. That's the theory behind it. And what we can do with the controls here, we can adjust gain on the main antenna and the phase and amplitude on the noise antenna to try and get the most desired outcome. Is that what you've experienced with your noise cancellers? Yep. Was yours a commercial?
Yeah, Qom Eliminator.
Right, so that is very, you'll see this later on. The other important thing for noise cancellers, there's a bit of magic that happens on the board. The other half of the magic is the antenna that you have. It changes for every specific application. Then whatever the noise antenna you're using, like I said before, it needs to pick up the local noise and try and not pick up your main signal that you're after. When I did use one at home, I did have a long wire stretched around probably 3/4 of my property along the fence, and it worked quite well. When you go and have a bit of a read online, or ask some people, the noise antenna actually needs to be really big. It needs to be just about as big as your main antenna. You can polarise it differently, you can have it lower, you can have it somewhere else. But it really does need to be big, because you want to pick up the same amount of noise as your main antenna. So there's no point having, in a lot of documentation, or when you go read about these, people say, oh, you just have a little probe, a little antenna picking up, and that's not so. To the point like where we've been trialling some of these units at Keith's house, he uses an off-centre fed, which is quite large for 80 metres against his vertical, I think. And the results are quite dramatic. As compared to when I first started using these in the shed, I just had a piece of wire stretched across the shed floor. I was thinking, wow, this thing's useless. But yeah, not so. So the noise antenna is really important. You got to really have a big noise antenna. You don't want it up too high, because the other problem with this is if you're receiving your voice or whatever you're trying to receive on your noise antenna, well, then you attenuate or you cancel out the signal on your main antenna. So yeah, it's trial and error. A lot of trial and error with the noise antenna will go a long way. Before we just talk about this, like there is a couple of different ways of cancelling noise. Well, everyone knows what the notch is. So, and it actually operates faster than your ear can hear it. It's trying to notch out repetitive noise. That's inside the radio. There's Dsp filtering, that's on the audio. So that's after the event. With a noise canceller, you're trying to, or what we're doing, we're manipulating the RF before it gets into your radio, which I think is a better thing to do. We'll see a video on it after. There is quite a few of these products on the market. The MFJ 1026, DX Engineering, Timewave ANC4. The ANC4, it's got a similar, well, all of these actually, a very similar circuit. The Qom Eliminator is very, very close to what this is, even from AliExpress. It's had a little bit of a look at it. It is quite budget. I don't know if I'd go out spending my $18 on that. Wemo, like I said, there's quite a few manufacturers, and they're all loosely based around this same kind of circuit. This is the Crossways. Can I go back? I think this is similar to the Qom Eliminator. This is an early one. This circuit is from 1989, I believe, from English fella. I can't remember his call sign. But a lot of these circuits of the machines the devices previously, all follow this principle. Where's the light? Ooh, back. How do I do the light again? How do I do the light? All right, there we go. All right, I'll just point. The mixing for the way these work, right? You have your main antenna. It's a bit blurry, I'm sorry. Your noise antenna. and your transmitter. And what happens when we're listening, we take the signal on the noise antenna and it's flipped 180 degrees through here, and we can adjust the phase and the amplitude, and we drive it into these two FETs, or we drive it into this FET here, and then the signal on the main antenna is driven into this FET, and we can adjust the gain. So we're mixing these two signals here in this section. One of them's put in at 180 degrees out. So really this here, it's a summing amplifier. So we get the sum of the two signals. And what's left is back out to the receiver. So hopefully you don't have your voice coming in here or your signal that you're wanting, and you're left with just that on your transmitter. Look at the similarities. This is another one. This is a Qom Eliminator. Same thing. It's the same design. Another very similar design. This is the ANC4. Where was it? That's between this section and here. That's the two mixing. They all follow this same principle of bringing the noise in and flipping 180 degrees and mixing it with the noise on the main antenna, or mixing the signal on the main antenna. It's a fair bit more complicated. There's a bit more involved in the ANC4. I did have a look at some of the earlier ANC versions. Wasn't as complicated as these, but not sure. How much is an ANC4 roughly, do we know? Is it about 200 and something US? I'm not sure. This guy, he is a fella in South Australia, and this is where I very first bought one of these from, before I decided to try and make my own. And as you can see, this circuit is very similar to the ones back from the late 80s from the guy in the UK. Exactly the same principle. You can see we're mixing the signal on the auxiliary antenna at 180 degrees with the signal from the main antenna, and we're feeding it back into the transmitter. So this is the first one I made, and although it worked really well, so this is my circuit. So you can see, literally exactly the same. This was a couple of versions ago. There's another thing I'll talk about in a minute. I've got lots of different versions as I keep going through the progression of my design. But it's the same principle. I actually drew the first circuit from the 1989 model, and then I modified it to be the same as VK2KU, Terry's version. Anyone got any questions on how it actually works? No. It's all based around a summing amplifier in the centre stage there.
You can do it open. I think it's pretty out of focus. It's very hard to see.
Sorry, mate. I don't know if it'll change. Sorry. So, actually, I'll show you. If you want to have a look at some of these, do you want me to pass one around so you can have a look? Yeah. That's one that's just come off the bench. This is a whole slather of versions of the printed circuit boards. Yeah, just throw them back. So on all these boards, as I go through, I've made mistakes. And I find them sometimes by letting some smoke out or on the bench.
Mistake, is it?
That one works. No, this is. Oh yeah, there's mistakes. There's one version that'll come around. You'll see some big isolation around the RF tracks. If you flip the board over, I've got a Dremel and I've cut a couple of tracks where I've made a few errors. that board that actually has the fix, the repair. See, I've cut the tracks. And there's another mistake around here underneath this relay. You see a little bit of wire hanging out under the relay. It's because I picked the wrong leg off the relay. It's what it's about, experimenting, isn't it?
Name of the game.
Yeah, that's right. So I've added, on every one of these noise cancellers that I've seen so far online, some of the features that I've sort of looked for haven't been on these designs I found online. One of them was having like an auxiliary set of contacts to drive like a linear amplifier, because that's what people may want to use. So that's hence the third relay on the board that's coming around. With these boards, it's very important that you have the push-to-talk hooked up. So push-to-talk is pulled out of your radio, just pulled low to ground, which will drive the relays in the other state. So when this board is listening, the relays are energised. So de-energise the relays for key up. If you transmit into the unit without having the push-to-talk plugged in, you let the smoke out. I've done that a couple of times so far.
Let the smoke out of what?
Out of the FETs. No, out of the FETs. Yeah, just. Oh, well, I put a diode on backwards, and I had my head right down nice and close on this blue frame. And I was powering up. I was going, why isn't this working? I saw a bit of smoke, and before I had a chance to pull my head back, it spat and hit me in the cheek. It's like diode jumped off the board and slapped me. Yeah. Yeah. So there is a few designs around there, and they have an RF sniffer instead of connecting to the push-to-talk. The reason I've stayed with the push-to-talk is it's faster and it's more definite. The RF sniffer, we've got a fella, VK2KU, who's made lots of noise cancellers in our club, and he goes by the RF sniffer. And he's had heaps of success as well, but every now and then I've spoke to him on the radio, he goes, oh yeah, I blew another one up. So we've decided to stick with the push-to-talk circuit. I've used all surface mount equipment on there, as you can see. And one of the problems I had with the original VK5TM, which is it's not a problem, it's a great unit, I just had problems getting the coax onto the board. Everything's through hole. My fat fingers put in a box, I broke one of the capacitors off the board. I know people probably think, how did you do that? I'm pretty heavy-handed. I'm a coal miner, by the way, so I'm very heavy-handed.
So they're not black.
Yeah, that's right.
So pretty heavy-handed, yet you can still solve a surface mount.
Yeah.
Yeah. Is there any questions? Feel free to speak out. Go.
What did you say about the output to linear?
Yep, so there's a third relay on the board, and that is just a set of discrete contacts on you'll see on the terminal strip, the screw terminals at the top. Yeah, just on your right, I think. Yeah, it's just a discrete set of contacts, so you can switch your linear on and off with it. Just pulls in and out. So that relay is working in the opposite logic to the two RF relays. So when you key up, that one turns on and the other two turn off, just to drive whatever you want.
But the same press to talk out of your radio could go to your linear.
Yep, it could, but when you plug it in, yeah, when you plug it in, then you don't have to have another plug, or you don't have to break into that same plug.
The other question I have for you is, do you have any attenuation on your main signal?
Yes.
How much? How much attenuation do you get?
It depends on your noise antenna. That's the experimentation part of the whole setup. And I don't think it'll be different for the Qom Eliminator, the ANC4.
1 to 2S unit attenuation.
Yep.
The noise drops down more than that, but the signal does drop down too. So if you're listening to someone who's just an S1 or 2, you know, right down low, and you turn the Qom Eliminator on, you lose them.
Yeah. Yeah.
You may not hear them under the noise anyway, so.
True.
Of course.
That's the
So that's expected, it's not a...
well that's the beauty of the noise antenna.
My noise antenna is a station master.
Who-
So the station master's going to do a good job of picking up the real signal as well and cancel that out.
Yeah, that's...
So I think the real magic, and this is a question I wanted to ask, I'm not trying to take over, but I think the real magic is in the difference between the two antennas.
Correct.
What your noise antenna can and can't pick up.
Well, that's
Correct.
Why vertical would be good, because vertical can take the noise, whereas my dipole is...
Vertical's still going to pick up a lot of it once it's 6 as well, isn't it?
Correct. That's 100.
Station master is 27 megahertz, whereas I'm trying to listen to 3 megahertz.
Your station master's still going to pick up some signal on 3 megs.
Yeah, that's 100%. That's Keith. Like I said, I'm not on HF. I've been over at Keith's place when he's used his, and it's an experiment. Like he's swapped over from vertical to his off-center fed to a long wire. It's just all trial and error. You know, different positions, different polarizations of the antennas. If you had the exact same signal on your noise antenna as your main antenna, well then theoretically you cancel the whole thing out and you'll be left with nothing. That's the ratio that you're trying to bring back, the signal to noise.
Is it worth actually having more than one noise cancelling antenna so you can try either of them under varying conditions? Or?
That's what this guy does. He's got a patch panel beside his set, and he'll change the noise antenna depending on the situation.
Just to tell you, I can't use 80 metres at my house. No matter what time of the day it is, it's 10 plus noise. So I can actually just take that switch over, or I can do that. And since I've used this noise canceller, I now join the net on Tuesday nights, and I have a ball. Yes, it does attenuate the main signal as well, but without it, I just hear noise, and I'm trying to do something. It's like, you ever heard bacon and eggs going, and you're trying to hear the guy talking, and it's just this noise, and it just fatigues you. But yet, when you use that, yes, your signals that are good and strong drop right down, but you still get, the noise is gone. The noise is gone, so you get all the people, so people that are S9, in the S9 noise, now drop to S5, but the noise goes down to 1. So I get
What noise antenna do you use?
I vary. So sometimes I even use a full off-center fed dipole for my noise antenna, or I use my vertical for a noise antenna. I've got some other antennas and I just chop and change to suit.
For 80 metres, which one do you use?
It varies, because it depends if my next door neighbour's got his air conditioner running.
No, an air conditioner.
Yeah, and some noise, I'll be halfway on a noise antenna, and then all of a sudden, even though it'll just go noisy, and then you just change antennas.
So just a little bit on right for me to go? Little bit on the evolution of this board. I like to work with surface mount equipment. It's might be a bit fiddlier, but it's a lot more robust. And I think it comes out as a bit more polished type product. The original design, and a few of the designs you see around, use 6-volt relays in series, and I was having a bit of a problem getting them. So I've gone back to 12-volt relays. The other thing, I had problems getting the surface mount inductors for a while. So I tried to get tricky and use through-hole components. I put the through-hole pads and the surface mount pads together, and I used to join them up. Until one version, I went along and I didn't join the edge of the surface mount pad with the edge of the through-hole pad. And I sat there for a couple of hours going, why isn't this working? I'm metering around, I'm looking at my drawing, and I eventually figured it out. And I think it's on one of these boards that's got passed around. I hadn't joined it up, so I had to put a big blob of solder to get this thing to work. The other thing that I really don't like about some of the designs is I mentioned it before, the RF connectors, trying to bring the tails back onto the board. It's painful for me. I don't know. So I've gone with these BNC's PCB mount, which there's one being passed around somewhere, which I think are better, easier. Once they're in, they're in. They're pretty robust. I'll be honest, they're not $15 connectors because we're only talking HF. We're not talking gigahertz. So that's probably $5 a piece, I think, or $4 a piece. Yeah, here we go. I don't know if people can see this. See, I've got the pads joined. There's another one somewhere where it's not joined. So that's a surface mount inductor, and you can see my through hole pads there for it. Now there's no more through hole components except for like the terminals, the pots, and the bits that need to be through hole. I went with 1206 size components because that's the smallest my hands can work with. All right, all the different versions. So this is a original VK5 TM version. You see bringing the tails off the board. Worked very well, by the way. And then this is where I've started to make my own versions. This was difficult. All the components way too close together there to solder. For me, my fat hands. And like I said, I've come across all these little improvements the whole way along, and every time I find one, I go, all right, and I've got to order another set of boards. And the last one, someone pointed out to me, I didn't have much isolation around the RF tracks, around here. Very small isolation, so I'm not sure if you had a bad SWR and you transmitted into this at 100 watts, I'm not sure how well that'll go. But I've sorted that out in the next version. Might be even sorted on this one. Yeah, you can see there's big isolation around the tracks there. These are before I added the third relay for the auxiliary. Yeah, lots of design. So I think here I've got up to version 9. I'm up to version 12 now. I never stopped making them. They've come forward. Yeah, I've only just added the third relay for the auxiliary set of contacts. Yeah, that's version 9. I'm up to version 10. I'm really up to version 12, but I didn't get the last two manufactured, so I've just kept it version 10. And that's in the post on the way to me at the moment. I order these boards through a company in China. Someone mentioned it earlier to me. It's no, JLC PCB. There's a lot of different manufacturers in China to buy these boards.
They're all the same block.
Yeah, that's right. I think so. I've actually got on really well with the people from JLC. They're even to the point where they rang me one day at home going, oh, you've got this problem on your board, what do you want us to do? And so they fixed it up. So, and they give me small discounts on one set of boards. One time you can add, like you can have, they're actually cheap, like really cheap to get made. A set of 5 boards to your house or to your door is about $15. As long as they're less than 100 by 100. Once you go over 100 mil, for some reason they like to charge.
What do you design your boards with?
Yeah, I use Eagle CAD. It's a CAD bit of software for printed circuit boards. That's what it looks like before you put it all together. It's components everywhere. A big mess. So I use Eagle CAD. I made my own. When you get printed circuit boards made from a PCB manufacturer, you supply them with this big file pack, and they're called Gerber files. And they're generated out of your printed circuit board bit of software. I made a custom Gerber file script, I guess you call it. So it makes it really easy for myself to get these boards made, to get made exactly the way I want it. It's taken a lot of trial and error with that. Like I said, there's lots of different suppliers in China, JLC, PCB, PCB Way, PCB Wing. There's a lot more. And the other good part about it is JLC, where I get most of my boards made, have a sister company, or like another offshoot company for components. And when you order a board or a set of boards, normally postage is quite dear and it's based on weight. But when you order a set of boards from JLC, you can go to this other company called LCSC, which is their, I guess, sister company, and order components, and the postage is free. So my last set of 20 boards I ordered almost a kilo of components. It was 900 and something grams, and I got the postage for free. It's unreal.
You can
So,
actually also, if you ask some of these companies, they'll even populate the boards for you.
yeah.
They'll solder them on, so you just get it and you're ready to just use it.
Where's the fun in that? You ain't get to let smoke out often if you do that. I looked into that as well. I even considered doing a silk screen, or I think it's a screen, and having a reflow oven, because they come up really, really nice if you do something like that. But I don't have the oven, not yet.
Toaster oven can easily be converted.
Yeah, I'm not sure how hot does it need to get, Keith? I'll just stick to soldering.
People have done it successfully in a
Does everyone know
toaster oven.
what that is? Like the screen process. You have your boards, and you have a screen that goes over the board, and you get solder paste, and you squeegee the paste over, and then drop all the parts on, stick it in the oven, and when it comes out, it looks professional. Not really, like a lot more professional than these. Altogether, probably the most expensive part on this board would be the the relays, then the BNC connectors, then the pots, and there's FETs. All together, I did a bit of a tally. The whole board, all the components on the board, ends up about $35, I suppose. And then there's a bit of time and effort putting one together. The boards, I guess, at the end of it, $3 or $4. And then the other thing I suggest about these, I'm not sure, what does the Qom Eliminator come in when you buy it? Well, yeah, very important that they're in a metal box, as we found out at Keith's. We had that plastic prototype one on top of his rig, and you can move it around and you'd be getting noise into it. Another thing with my design, and I figured this out early in the piece, is the ground plane on the boards. I actually now do double-sided ground planes. Yeah, a little bit of difference. There's a little bit, like a lot of places, a lot of boards you see only got a single-sided ground plane. Now I've learnt how to do the two sides, and yeah, trying to keep noise out of everywhere. Because if you get noise on this, you can't cancel it, because noisy antenna's not going to pick that up. Yeah, like I said, very important that it's in a metal box. Yeah, there we go. Everyone knows about using the ferrites around all their cables. They're the benefits of being in a metal enclosure like we talked about. Why did I make this? I guess someone might ask. One, I was experimenting with Keith. Also, I want to make it reproducible. I don't know. I did make a APRS, like TNC, for a balloon a while back. I did it on a bit of breadboard, and it worked great. But then I tried to make another one, and it didn't work great. So And the first one was yeah, I don't know. It worked really well for some reason. We put it in a balloon from Yass and we let it back in the ocean over near Manana. So everything went great. And the second one I tried to make did not work at all. So that's where I started making printed circuit boards. When I ended up making these, they're repeatable. Like, so I'll be honest, hand on my heart, I haven't had one totally dead board yet. And if I've ever let some smoke out, it's been my own stupid fault to put a diode on backwards. I've got a short somewhere, I've got too much solder on something, shorted 2 tracks. So every one of the boards I've made so far has worked. I had all my indication working back to front on one of them. Yeah. Yeah, like I said, using professionally managed PCBs, it's repeatable every time. It takes about 3 hours to put one of these together, and because it's down in my shed, I've got my fridge right next to where I work, so there's a few beers, and I'll let my kids know not to come in the shed when I'm having a bit of a hard time. Like I said, I'll let some smoke out. It's quite exciting sometimes. Got a big power supply. Got a big power supply down there that can drive any board, any component off the board that I try. So, yeah, but it's always a bit of fun. Here is an experiment. It's a video of one. I'm going to try and get this to play. I'm not sure. So it's pretty effective.
Signals dropping from nearly S9 down to S3.
Main signal and all the noise. Yeah. All the noise with it. Yeah.
So if you're on a net and people are asking what signal strength am I to you, I've got to turn the Qom Eliminator off and then tell them what they are and then turn it back on so I can hear them.
But is that...
The question is, how much higher are they because of the noise? I mean, would they be a 6 and there's 3 of noise on top, moving the meter further? So you don't know.
Yeah, like this when you. I can't comment too much because I don't really get on HF a lot. But if they're saying what signal strength am I, like, and you're looking at noise.
But everyone wants to hear a big number.
Yeah.
Well, give them a big number.
You just tell them that you can just say it's a 3, but I think you would probably be a 6 because I have a noise canceller here.
Or I'm on a Kenwood.
Effective. There's a lot of other things happening in the background of the radio too, Dsp, I think.
Oh, I don't pretend. This is not the magic bullet. Noise is noise. It's something that helps. It's not a miracle cure for noise. The cure for noise is to go somewhere where it isn't. We don't all have that luxury. It's just something that I picked up and ran with and spent a bit of time and effort and did a fair bit of reading on and decided to come up with my own for lack of having onboard RF connectors, having the other features that the other boards don't really have. And it's worked well for me so far.
There's only a couple of radios that use the first event and input, don't they? There's a few brands that are floating around.
And they have an inbuilt noise canceller. I think the main thing, what everyone should really focus on is that noise antenna. You need to experiment, and you need to not just have some small little piece of wire, strung over the back of it. Yeah. Yeah.
Doesn't do anything.
Yeah, no good.
Can I ask, the transformer does the 180 phase shift.
Yeah.
What does the phase plot do?
It's just adjusting the gain. There's another thing I'll just mention.
Plot, not the gain plot.
Oh, okay, so the gain on your main antenna, the signal strength coming from your main antenna in, there's a gain. Well, it's like, can I go back? This is the gain on the main antenna, so you can just see it's the signal. Like this is drawn in the keyed position, so when it's listening, you're just adjusting the gain on the main. All right, so this is the. Yeah. No, that's just the main antenna. So you're not that's just the signal coming in. Here this is the phase. That's phase 1 and phase 2 on the noise side. You're just adjusting one side lower or higher of your output of your, I guess, your phase shift. This is the 180 degrees shift in that little toroid. You're just adjusting the signal, like the strength of that phase shifted signal in the amplifier each side. This will null out like a higher or low, and then this will just swing the signal towards your high or low side, depending on how you've set the phase 1 up.
So it's just an RC circuit which gives a little bit of a phase shift.
Yeah.
You only need sort of half a cycle or thereabouts.
Yeah.
Microseconds.
This is only this circuit here, the 2 pots, is just I guess just adjusting the gain coming from that 180 degree transformer. Is there any more questions?